Mainly we have two types of rectifiers. One is half wave rectifier and the second one is full wave rectifier. Why the names are half wave and full wave? If we give a input sinusoidal waveform, if the output is only half wave, then we are calling it as half wave rectifier. Instead of that, if output is full wave, then we call that as a full wave rectifier. Now we are discussing about half wave rectifier. In this half wave rectifier, we have a transformer, which is a step down transformer, means the secondary winding layers are less than the primary windings. I have taken an iron core. So this is a iron core transformer and a diode. We have used a PN diode. We are giving input AC voltage because I want this AC voltage to be converted to DC. And what is this voltage value? 230 volts RMS. What is this RMS? My voltage is not constant. My voltage is fluctuating throughout the cycle. So I cannot give a single value. For example, if you are writing examinations, 10 examinations you have written. In the first examination, you have scored 90 out of 100. In the second examination, you have scored 0 out of 100. And in the third examination, you have scored 25 out of 100. Now, if I ask, what is the score you are getting in examination? Then you will definitely tell, you may tell, I have got 90. So you are telling the maximum value only. We call this as an amplitude. Then I ask you the question, you have got 90 only one time. What about the remaining examinations? Then you will tell, okay, the remaining examinations marks are like this. So here also we are getting the remaining voltages. Every time the voltage is not maximum. That's why we are taking all voltages. We want to perform the average, mean, root mean square. But when we perform the average of this signal, average will be 0 because we have positive and negative voltages. In order to find the average for this signal, we are squaring each and every value and we are considering the root. That's why we are calling this as a root mean square value. Now the root mean square value of the input AC supply is 230 volts. This supply is given to the transformer. This is a step down transformer. Now it is stepping down the voltage. This voltage we have connected to the diode. As we mentioned, because this is an AC, we have positive cycle and a negative cycle. During the positive cycle, the terminal A becomes positive with respect to the terminal B. Because the terminal A is positive, the diode anode is positive with respect to the cathode. This diode is in on condition. When this diode is in on condition, this simply behaves like a wire. During the positive half cycle, entire voltage is given to the resistor. And during the negative half cycle, terminal A becomes negative and terminal B becomes positive. At that time, diode is in off condition, so there will be no voltage to the resistor. During the positive half cycle, as we mentioned, entire voltage is being given to the resistor. But practically, there is a small voltage drop, that is 0.7 volts for silicon diode and 0.3 volts for germanium diode. There will be practically small voltage drop. Apart that, the entire voltage what we are giving, the positive waveform, you can observe here. This is the input voltage. Whatever the input voltage we are giving, the same waveform, the positive waveform, you can observe here, we are getting the positive half cycle. But negative half cycle is not coming. At that time, the diode is in off condition. During the negative half cycle, diode is in off condition. So negative half cycle is not coming in output. That's why this is called as half wave rectifier. This is output voltage waveform and this is output current waveform. This is output voltage waveform VM. This is the amplitude and this is output current waveform, amplitude is Im. This is how we have rectified AC, and this rectified waveform is called as pulsated DC. In this pulsated DC, we have ripples. These are ripples. By using the filter, we will remove these ripples. We will later learn what is filtering.